Okay, this is 8G1, 8th grade geometry standard 1. We are going to verify experimentally the properties of rotations, reflections, and translations. This is video 1, and we are going to do translations today. Here are a few terms to know. I'd like you to write these down in your journals and make sure you define them. All right, let's first talk about what a translation is. A translation is a transformation in which every point of a figure moves the same distance in the same direction. Now, what we have here is something called a rotation rule. This is a coordinate rotation rule. It looks very scary, but I just want you to know that this is a coordinate. This is an ordered pair XY. And all we are doing to each of the x and the y's are we are either adding a value to it or we are going to be subtracting a value from it. And that's going to be just moving the picture or polygon around the grid. And if you think about the word translation, you can think of another word in the language called transportation. And when you transport something, what are you doing? Think of transportation, class. Yes, Daniel. You're moving something. And what types of things do you come across in the world every day in which we transport or move something? DJ.
The mail delivery guy. He transports mail.
Okay, so the mail delivery system transports mail.
Bus.
Nick?
Bus.
Buses, can you say a little bit more to that?
It carries us, the students, to Gemini from our houses and from Gemini to our houses.
Very good. Now, does the bus ever change in shape or does it just move across the city? Good, it just moves across the city. So when we take a look at an actual picture or a polygon on this grid, what type of figure do you see here? Joseph?
A triangle.
You see a triangle. And how many sides are there on a triangle? 3. And how many ordered pairs do we have at our vertices? Now a vertice is where our line segments meet up with each other. So how many vertices do we have? Yes. Angelina? 3. We have 3 vertices. We have a vertex at point A, point B, and point C. Now, if we are following our coordinate notation, looking up here, what's going to be happening to all of my x coordinates when I start translating this figure around? Well, what's going to happen to the x's? All of my x's are going to do what? Daniel? They're going to be subtracted by 6. So if I'm taking this point A right here and I'm going to move it along the x-axis, what direction will I be moving this figure and how many units will I be going? Left, very good. How many units? -6. So we're going to be taking point A, and according to the notation, we're going to subtract 6 units from that A. So let me take out a pen here, and we're going to go back. This is the x-axis is horizontal, right? So we're going to go left 6. 1, 2, 3, 4, 5, 6. And I'm going to give it a new name because it's a new picture. Instead of calling it A, I'm going to call it something called A prime. And A prime is like this little apostrophe looking notation. Okay, now if I do that to vertice A, I must also do that to B and C. So where should I move point B? Mark? Below point A. So how many units should I be moving point B in what direction?
6 to the left.
Okay, 6 to the left from where we're at. 1, 2, 3, 4, 5, 6. And what do I need to call it? Because it's no longer point B, I am moving it or transporting it somewhere else. Janera? B prime, very good. And then if I do it correctly, I'm going to also be moving point C somewhere else. What direction and how many units? Nick.
We'll be going left and 6 units.
Okay, so we're going to go left 6 units. 1, 2, 3, 4, 5, 6. What am I going to call it?
Prime.
C prime. Now, have I done all of the notation? Should that be my final answer? Is that where I should be stopping this new polygon? No, why not?
Of the y-axis.
Oh, okay. So we didn't take care of the y-axis. We didn't do any movement or transporting on the y-axis. So what direction does the y-axis go? Any new hands out there? So what direction does the y-axis go?
Positive.
Positive? Okay. So what does that mean, like in terms of a direction?
Right.
Up and down. Very good. So now I'm going to be taking these A, B, and C primes and relocating them either upward or downward because that's what the y-axis is. So where am I going to move it according to my notation up here in the given problem? Samantha. Up how many units? 2. Okay, so now we're going to take this. Maybe I'll just do the point and we'll move the A prime. So we're going to take this point and move it up 2 because we had a plus 2 in our notation. I'm going to take my B prime, move it up 2, and then I'm going to take my C prime and go up 2 also. So my new picture, when I translate it 6 to the left, watch it now. 1, 2, 3, 4, 5, 6 units to the left, and how many units up? Good. 1, 2, and there we have a translation, a movement of our polygon from one part of the grid to the other part of the grid. Okay, now let me fix that 8 prime up there. Okay, you see the difference? We're shifting the polygon. Okay, now I would like to describe this transformation in words. So what happened to get from polygon ABC down here to A prime, B prime, C prime? Can anyone see what kind of movement we did here if we were to use coordinate notation or a verbal description? What do you see happened here? Go ahead.
The x-axis was subtracted by 4.
Well, hang on, because we're going from A to A prime. So we didn't subtract on the x-axis.
Oh,
Yeah, we added because the x-axis goes what direction?
right and left.
Right and left, horizontally. Okay, so if I go from A over to A prime on the x-axis, how many units did I go? Can you see that?
Yeah, 4.
You say 4. Let's count them out. Count them with me. Ready?
1, 2, 3, 4.
Good. So we are translating 4 units to the right, and what's next?
4 units.
Downward.
Or no, the B has to go 4 units.
Well, I'm going to the A prime, so I'm going from A to A prime. How many units downward? Count with me, everyone. 1.
2, 3, 4, 5.
Okay, so we went to the right 4 units, and we went down 5 units. So that is how you would do it verbally with a description. And if I were to use coordinate notation now, I would say x, y translates to x. What did we do with the x? We added 4. And what did we do to the y? We subtracted all of the values by 5. Okay? And our last one, what they want us to do now is they would like us to take these ordered pairs, put them on a grid, graph them, call them P, Q, and R, and then follow the coordinate notation and have your new prime P, so Q prime and R prime, and see what happened with that picture, moving it across. And a lot of video game production companies use this idea of grids, how they move those characters across the screens. A lot of real world life examples that you can have that use this type of technology here. So let's see how that looks. So if I'm going to graph negative 5, 4 and call it point P, 1, 2, 3, 4, 5, up 1, 2, 3, 4. What do I call that, everybody? Point P. Q is going to be 1, 4. So we go 1, 1, 2, 3, 4. And then we call that what? Q. Q. No, just Q. This is our first picture. We're not moving it yet. And then R would be at 1, 1. We'll call that R. And let's see if I did that for you already. Yeah, I think I already got that set for you. And there is our first polygon. And now according to the coordinate notation, we're going to be translating that where? What does that coordinate notation tell us right here? Joseph?
X to the right 1 and then y down 6.
Okay, so we're going to go this whole picture to the right 1, and then we're going to be moving it down 6. So let me just take a nice purple marker here and set that up for you. All right, so point P, we're going to go right 1, down 6. 1, 2, 3, 4, 5, 6. And what do we call that? Good, P prime. I'm going to do the same thing to Q. I'm going to move it to the right 1, and how many units down? 1, 2, 3, 4, 5, 6. Q prime, good. And then R prime will be right 1 and then down 6. 1, 2, 3, 4, 5, 6. And if I did this correctly, I can duplicate my triangle, which I'll do here in a second, and it should line up right on those prime points. Let's change its color. How about that? Okay. All right, and now we label it with our primes. Okay, and where we're going with this later on in the semester here, we're going to be talking about other types of transformations like rotations and reflections, and we're going to get into like double primes. So they're going to ask us to maybe translate it with notation and then rotate it according to certain rules. So we're going to have two different movements here. We'll call them double primes. Okay, in your journals, I'd like you to define the given terms on page 2 of your flip chart. Write down a few of the sentences on what you think you learned from this video. And if you have any questions, obviously I can answer them today, or if you're watching this later on for study purposes, we can do that during our review.